De Broglie relation. We know that light has dual nature. Sometimes it behaves as waves and sometimes it behaves as particles. Interference and diffraction demonstrate wave behavior, while emission and absorption of photon demonstrate the particle behavior. Louis de Broglie in 1924 proposed that particles should also behave like waves under certain circumstances. Louis de Broglie argued the following. The photon had been observed to be emitted and absorbed as discrete bundles of energy. The energy of photon is given by E is equal to hf. Also, the momentum of photon is given by E is equal to pc. Comparing two equations, hf is equal to pc or lambda f is equal to c. This is a relation between the wavelength lambda, a parameter associated with wave motion, and momentum p, a parameter associated with particle motion. From this, a relation is obtained: lambda is equal to h over p. This relation is applicable to both photons and material particles such as electrons. Explanation with examples. Calculate the wavelength associated with number 1. An object of large mass and low speed. To calculate the wavelength associated with an object of large mass and low speed, we assume a bullet of mass 20 gram flying with a speed of 330 meter per second. Then, using the relation lambda is equal to h divided by p is equal to h divided by mv, lambda is equal to, putting all the values, 6.63 multiply 10 raised to power minus 34 divided by 20 multiply minus 3 multiply 330. We get the wavelength 1 multiply 10 raised to power minus 34. This wavelength is so small that it is neither measurable nor detectable even by diffraction grating. Now calculate the wavelength associated with number 2, an object of very small mass and high speed. To calculate the wavelength associated with an object of small mass and high speed, we assume an electron moving with a speed of 10 raised to power 6 meter per second. Then, using the relation lambda is equal to h over p or lambda is equal to h over mv. Putting the values, lambda is equal to 6.60 into 10 raised to power minus 34 divided by 20 multiply 10 raised to power minus 3 multiply 10 raised to power 6. Wavelength is 7 multiply 10 raised to power 6. This wavelength is in the X-ray spectrum and hence measurable and detectable through diffraction effects for electron.